been a very great conference. So this afternoon we have the pleasure of having first Elaine Landry from UC Davis, who's going to talk about structural realism and category-theoretic.
Thank you. So, as everyone else did, I also want to thank the organizers, and particularly Chris, and extend a welcome to Carl and staffers. I also did my PhD here many years ago, and so consider well, thank you. So, you know, as someone who is still, I think in my mind, part of the Western family, I wanted to particularly welcome Stathis, who have inspired me not only to be someone who's careful about philosophy, but someone who's generous and who's kind and who's very principled. And so you've inspired me to do good philosophy, but to be a good philosopher. So thank you for that. So I'm going to talk today about structural realism and category mistakes. I'm just going to give a brief introduction. Hopefully I'll get through the talk because it is quite long, so I apologize for that. Because it is long, I'm going to have to read because I can't remember what I said. So here we go. So for the structural realists, I'm going to argue that simply replacing a set theoretic formal framework with a category-theoretic one is a category mistake. So while there might be good reasons to suppose that category theory can offer a better framework for the concept of shared structure that's used to account for the structure of scientific theories, and there's some interesting work coming out of Hans Holmsen on this, that this use is distinct from that needed by the structural realist to account for the structure of the world. Presumably, that's the structure that the structural realist wants to get at. So if we appreciate against Old French, and I put that in because Steve said, I changed my mind and it's not fair, so I say Old French now, that as structural realists, we ought to be focused on the object level of scientific practice and not on the meta level of the philosopher of science. So the philosopher of science being concerned with the structure of scientific theories, and I see structural realism as occurring at that object level, and hopefully that will become clearer what I mean. So if we make this distinction, we can better see where our mistakes lie. So my aim here is to critically examine recent claims by Bain and argue that he too falls victim to a similar category mistake. So Bain's claims for what he calls the, I don't know if I remember what this is, but it's the radical, thank you. You have the eliminationists, the radical ontic structural realist use of category theory are founded at the theoretical level. That is, they're concerned with the mathematical structure of the scientific theory and not with the physical structure of the world. And consequently, they're of little help to the structural realist, whether he's an advocate of Bain's radical ontic structural realist or Lam&Wüthrich balanced ontic structural realist. I remember that one. And against the criticisms forthcoming of Lam&Wüthrich, that I'm going to argue that Bain himself intends mathematically to show that one can use what I'm going to call a Hilbertian reading of category theory to answer Psillos' question of how we can have relations without relata or talk about structures without objects. So I'll use category theory so considered to conceptually show that there is no distinction between this balanced view and this radical view. So Bain argues that category theory provides a better formulation for this view of structural realism, namely the claim that structures exist independently of objects that may instantiate them. And his argument is twofold. So he says category theory provides a more general notion of structure than does set theory, and that specific examples from fundamental physics show that category theory is better for running these structural realist type arguments. So claim one has two components. The first is conceptual, so it aims to show against those that hold that there's a type of conceptual dependence between relations and relata, that category theory, or more specifically the category of sets as framed topos theoretically, makes coherent the claim that one can speak of relations without relata. The second component is mathematical or more general in nature, and he aims to show that category theory provides a more general formulation of mathematical structure than do both set theory and the category of sets. And this because, he says, a structure is an object in a category, and so category-theoretic objects need not be structured sets. So Bain next seeks to bring these two components together to form the basis for his arguments for his view of structural realism. He says to guarantee that this mathematical fact, that is, that category-theoretic objects need not be structured sets, has physical significance, the structure-theoretic ROSR must provide examples of non-structured objects that have a role to play in articulating the relevant notions of structure in physics. So category theories claim to provide a better account of the mathematical structure of at least two fundamental theories of physics. This, together with Bain's naturalized metaphysical stance and his semantic realism, is taken to license his structural realist claim that category theory provides a better account of the physical structure of the world, so that one ought not to be committed to, one only ought to be committed to structure, and that this notion of structure can be claimed to exist independently of any objects that instantiate. So it's by use of two examples from fundamental physics and a two-pointed analogy that Bain seeks to underwrite the claim, or the components for claim 2. The two examples are as follows. He says, these are the examples from fundamental physical theories. The category-theoretic formulation of sheaves of Einstein algebras of general relativity, and you don't need to know what that's not called, the argument, shows that the invariant structure, and in this case he's claiming its global differentiable structure, cannot be predicated on space-time point correlates, that is, on maximal ideals. So we have a case of freestanding physical structure, that is space-time structure without objects, that is without space-time point. His second example is the use of carve and Hill, both of these being categories in topological quantum field theories, to show that non-set structured objects play a role in fundamental physics. For example, that objects cannot be considered as structured sets, since they're morphisms of not functions and they don't emit a Cartesian product. So again, we have a case of freestanding physical structure without set objects. So these are the two examples that he's using to make his structural realist argument. Then he runs a two-pointed analogy to beef up his claims. So he says, just as the point correlates in the Einstein algebra models of GR do not play an essential role as relata in articulating the relevant notion of structure, so the correlates of set theoretic relata, by this he means elements in category theory, do not play an essential role in articulating the relevant notion of structure, insofar as in general, objects in a category need not be structured sets. His second pointed analogy, just as the sheaved theoretic Einstein algebra models of GR provide a more unifying description of phenomena insofar as they belong to a single category, whereas the tensor models of GR do not. So the sheaf theoretic notion of structure does what he says actual work in providing a more unifying description of the physical phenomena. So Bain concludes then by saying that his ROSR is justified in the claim that structures exist independently of objects at three different levels. So conceptually, because we can use set to eliminate elements qua relata by taking them as arrows. So in the category of sets, global elements are given by arrows. So set makes coherent the claim that we can have relations without relata. Mathematically, because a structure is an object in a category, so structure theoretic objects need not be structured sets. Thus, the structure of objects does not depend in any essential way on their elements. And finally, physically, because the use of sheaves in GR and carve and Hill in topological quantum field theories provide examples of non-structured sets that have a role to play in articulating the relevant notion of structure in physics, while eliminating reference to their elements. So far, so good. But according to Bain, there remains a mathematical concern. So one might also argue that the generality afforded by the category-theoretic definition of structure is a moot point if it turns out that category theory presupposes set-theoretic concepts. So the ROSR, in addition to having to provide a category-theoretic reformulation of theories in physics and show that the structures that are physically relevant are not set-structured, is left with another task, one that he doesn't take out in his paper, and she should provide a rationale for the fundamentality of category theory over set theory. Okay. So in a recent article, Lam&Wüthrich, you're going to argue against the claims made in Bain, and they're going to say that Bain's arguments are not strong enough to decide between ROSR, which claims to have eliminated the need for objects, and BOSR, which is, they claim, a more balanced view, which claims that, well, only a thin notion of object is needed, nonetheless, objects aren't eliminated. So we're going to investigate what it could possibly mean to say we have a thin notion of object. So let's look at their arguments. Their arguments are based on two central considerations. The first is that there's a notion of conceptual dependence of relations upon relata, and that's understood in three distinct ways: metaphysically, mathematically, and physically. They say the metaphysics first option doesn't work because we're still going to require a notion or an explanation of compresence that does not passively rely, at least on there being a thin notion of relata. In regards to B, that is the mathematical account, they claim that Bain's category-theoretic account of mathematical structure fails for two reasons. So Bain must show that mathematically, contrary to set theory, the notions of freestanding relations and structure do not require the notions of relata and objects, and that the category-theoretic notions used to capture mathematical relations cannot be isomorphically reformulated in set theory. Otherwise, we don't have an elimination, we just have a mere relabeling. With respect to C, that is the physical attempt, they say that Bain's category-theoretic account of physical structure fails for, again, two reasons: that Bain must show that physically fundamental physics can be reformulated in category-theoretic terms without this set-theoretic equivalent, and that category theory, or the category-theoretic reformulation, is somehow superior to the set-theoretic formulation, and in particular to the usual set-theoretic understanding of the notions of structure and relation. So the physical relations, again, cannot be isomorphically reformulated in set theory. Otherwise, again, we have a case of relabeling and not eliminating. So they next note that it's not the intention of the ontic structural realist to be a mathematical structuralist, so they then focus their attention on physical structuralism. And this underwrites their second consideration. They claim that in two of Bain's examples, he's not shown that the objects are eliminated and not merely relabeled, and in others, he's not shown them to be physically significant or set theory free. So in both the set and EA examples, that is the Einstein-Algebra examples, Bain cannot presume that the relata, and the relata in the set example are taken to be elements, and the relata in the EA examples are taken to be manifold points. He says, look, you can't say that those are eliminated and not merely relabeled. Okay? In the sheaf theoretic formulation of Einstein algebras, they claim that the justification for this physical significance is rather mute, and that sheaves themselves have elements, that is, they're defined over open sets constituted by points of the underlying manifold. So again, these points of the underlying manifold are taken as our relata. We haven't eliminated relata. We merely renamed them. Finally, in the N-Cobb and Held quantum field theory example, Bain has shown that set objects are not essential, but he's not shown that topological quantum field theory is more than a tool or a toy model. So that's their objection. And they conclude that Bain, as an advocate of ROSR, has not met his aim either mathematically, because we could reformulate our category-theoretic notions in set theory, or physically, because he hasn't shown that these uses are essential in fundamental physics. Note, however, that at least some of these mathematical claims are the result of Lam&Wüthrich's confusions and conflations. So Set is used by Bain to underwrite the conceptual coherence of the claim that in defining set relations, and so set structure without elements qua relata. So they have two aims, or Bain has two aims. One to show that it's conceptually possible to talk about relations without relata, and the second is that one can use more generally category theory by taking a structure to be an object and a category to underwrite this claim of mathematical coherence of the claim that structures can exist without set objects or without objects more generally. So why is this crucial point missed, and more importantly, to what extent are these and other confusions the result of Bain's own category-theoretic mistakes? So if you've read the Bain paper, there's some problems. And there's some problems that one finds standardly in the literature, in that people tend to open a book in category theory and they pull out a definition and they don't know where that definition comes from and how it works. And so I want to make the following claim that Bain has misunderstood and confused the various category theoretic levels, and so to the various types of structure. And this shows that it makes no sense at all to say that a structure is definitionally or even informally an object in a category. And the second is that he's conflated this theoretical level of mathematical representation of the structure of the physical theory with the object level of the mathematical structure of the physical phenomena. And it's only when we look at the mathematical representation of the structure of physical phenomena that we can run the structural realist argument that Bain wants to make. So however, given his naturalized metaphysical stance and his structural realism, his semantic realism, his view of structural realism might be saved if it can be shown that the mathematical structure that does physical work, as he claims, that does the work in mathematically representing the structure of the phenomena of physical theories is category theoretic. And I'm going to show that I don't think he's fulfilled the second aim. So I'm going to go quite quick through this because I don't know that it matters, but I think that we have to understand what's going on in category theory more generally. So there are at least three levels used for categorizing category-theoretic types of structure that must be distinguished. So at one level we have the Eilenberg-MacLean axioms, and they characterize types of structure in terms of their objects and arrows. So set characterizes set structure in terms of taking our object to be a set and our arrow to be a function, so forth and so on. But notice here that we don't have to restrict ourselves to algebraic models. We can also look at geometric models. We can look at proof-theoretic models. So for example, the category of deductive structures characterizes proof structure in terms of taking formulas as arrows, formulas as objects, and rules of inference as arrows. And I've given the characterization of Pilb and Enkov. We can go through that. So that's one level of analyzing category-theoretic structure. The second is using the ETCS axioms, or the elementary theory of category sets, as given by McClarty, to characterize the internal set structure of the category of sets itself. So when we do this, we logically characterize the structure of objects and arrows of set by offering a topos, or internally logical theoretic account of set structure. So in a topos, we're really looking at set structure. So as noted in both Bain and in the Lam&Wüthrich article, unlike the usual set theoretic formulations where membership is primitive, in a well-pointed topos, which is both Cartesian closed and has terminal objects, a global element of an object in set, so a global element of a set, because those are the objects in set, is defined as an arrow from the terminal object of set, terminal object of set to A, that is a member or an element. So the question then, right, remember what Bain wants to use this for is to say, look, we don't require this notion of element. And then Lam&Wüthrich come back and they say, okay, but look, when you say arrow, I could just say element, and you're not getting rid of elements, you're just relabeling. But let's stop for a minute, right? What are we trying to do? We're trying to show that we can have relations without relata. And this notion of arrow here is not a relata. If anything, it's a relation. So I think in that example, I do think Bain wins that argument. I think that there's no way that one can characterize that arrow as a relata. That's just to misunderstand what's going on. But neither the EM axioms or the ETCS axioms get us to Bain's more general definition, that is, a structure is an object in a category. And I have no idea what he means here. So one thing he might have in mind is that a type of category-theoretic structure can be characterized as an object in a category. So this brings us to our third level of analysis, the CCAF axioms, or the category of categories as an axiomatic foundation given by Levere. And here we characterize category-theoretic structure, or the structure of systems that are themselves categories. So in CAT, we take our objects to be categories and our arrows are functors. So for example, set, group, dead, all of these can be taken now as objects in their own right. And we can analyze the relations between themselves or between other objects in terms of functors. But again, this doesn't get us to a structure is an object in a category. It gets us to a category can be categorized as an object in CAT. That is the category of categories. But such objects come with arrows, right? You can't just say a category is an object. Right? In CAT, you need both the objects and the arrows, because both of those do their work in characterizing the category-theoretic structure. And there are also technical issues, which I mentioned down here, if that's what he means. Using CAT comes with what are known as size issues. We can discuss that in a minute. But before I move to my next point, I consider yet another possibility of what Bain might mean by a structure as an object in a category. So Levere showed that the structure of any algebraic or equational theory can be categorized category-theoretically so that its models are functors. So the result was extended by Levere, Macaulay, and Benabou to any first-order theory. So one can give a category-theoretic kind of characterization or formulation of the structure of a scientific theory in terms of its functors. So we have a category-theoretic categorization of the structure of a theory in terms of its model without having to invoke a semantic syntactic distinction. So recent work by Halvorsen is working at this project. But notice that this is about the structure of scientific theories. It's not about the structure of a particular scientific theory. So Lam&Wüthrich seem to consider this interpretation, but again, confuse and conflate what's going on. So they note that on this reading, the category as a whole articulates the theory and its objects represents the models of the theory, which is right. But it doesn't represent physical objects in their own right. And I agree with this. Just as I claimed of French's set theoretic partial structures approach, that one must be careful not to confuse the level of philosophy of science, which considers the structure of scientific theories, and the object level, which considers the structure of the world. Right? So again, we can't say, well, I can move from the structure of scientific theories to the structure of the world. Presumably, we've got to capture something that has empirical content. So as Lam&Wüthrich remind us, the physical claims of the structural realists are not to be underwritten solely by mathematical claims. But in the spirit of what Bain intends to show, does category-theoretic mathematical structuralism have anything to offer the OSR at the conceptual level? So can it be used to answer Psillos' question about how can we talk about relations without relata or structures without objects? The more general question is, can category theory be used to show that one can talk about systems that have a type of structure without having to concern ourselves with what these types are or what they're made of? Right? Whether we want to say they're made of sets, and so, oh, category theory requires set theory, or made of elements. Oh, you need relata. So the answer is yes. Okay. So I've argued extensively, and several other people have, McKee, Audi, McCarty, that it's precisely in this sense that category is a better foundation for mathematical structures. It provides an organizational tool for unifying what we say about systems that have a type of structure without our having to concern ourselves what these types are in some ontological sense or what they're made of. So moreover, what I want to do now is I'll show using a simple category-theoretic BOSR style argument can be used to collapse the distinction between relabeling and eliminating, and so collapse the distinction between ROSR and BOSR. So recall that Lam&Wüthrich claimed that what's at stake between ROSR and BOSR is that ROSR eliminates objects and BOSR retains them but as thin. So what is this thin notion of object that's at the heart of BOSR? So what we're told is that the typical picture offered is of a balance between relations and relata, coupled to an insistence that these relata do not possess their identity intrinsically, but only by virtue of occupying a relational position in a structural complex. Okay? But this doesn't distinguish BOSR from OOSR, right? ROSR. It's just the structuralist slogan that objects are positions in a structure. ROSR says that's all there is to object, and BOSR says no, something still remains. So shifting then from talk of relations and relata to talk of structures and objects, where does this difference lie? So we're told that ROSR, by eliminating objects, escapes any of the known headaches concerning the identity of these objects, while BOSR does not. And so this brings us into issues taken up by Simon Saunders about identity conditions. But how does one escape these questions and the other does not? So I'm going to run an analogy with BOSR's article, or his argument that numbers are not objects. So remember that in his paper, I think called Numbers Are Not Objects, according to BOSR, numbers should not be taken as Freudian, no entity without identity objects, because as the Ernie and Johnny interpretations show, numbers have no intrinsic identity conditions set out other than those set out by the axioms. So that it's true that in those systems that have that structure, right, that satisfy those axioms, the positions might have other intrinsic properties. I couldn't get the element relation here, so. Right, so in one system you might be able to say 3 is an element of 17, right? And in another system you might not be able to say that, so that's an intrinsic property. But what BOSR inspires the structuralist to do is to argue that what a number is based solely on its being a position in a system that has that structure. So far then, both OSR and BOSR positions line up with BOSR. We have objects are a position in a structure. So now let's consider from a philosophy of math perspective what it might mean to say that BOSR still has known headaches concerning the identity of these objects. So now I'm going to take a little foray into mathematical structuralism. So mathematically speaking, two possible replies. We get the reply of the set-theoretic foundationalist and the mathematical structuralist. So the first reply is that once we decide which set theory is the set theory, and so which set theory is the foundation, we'll rule out one of those interpretations, whether it's Johnny or Ernie's or whoever else's, and it provides the identity condition for numbers as sets. That's what the set-theoretic foundationalist project is supposed to get us. It's supposed to get us stability of reference, or identity conditions in Freudian terms. The mathematical structuralist replies that numbers just are positions in the structure. They don't have to be reduced set-theoretically. But there are two ways to understand this claim. So the anti-REM structuralist, like Shapiro, says that the positions are to be taken as instances of places, and these places are places in these Platonic structures, these structures that exist independently of any system that has that structure. And then he goes on to provide axioms for a background theory that provide the conditions of actuality for those Platonic structures. Our other option, as a mathematical structuralist, is the in-ray position, of Hellman, for example, that says no, position refers to a position in any or all systems that have the same structure, that are isomorphic. All right. And then Hellman goes on and he provides this modal nominalist background theory for talk about the possibility of such systems. So Shapiro's providing actuality conditions for structures, and Hellman's providing possibility conditions for systems. What they both have in common, and the reason why they feel the need to add these background theories to provide identity conditions for positions, is that each sees the mathematical axioms as Phrygian. So they've given up on the Phrygian notion of object, but they've held on to the Phrygian notion of an axiom. So they both see axioms taken as truths about a fixed subject matter, be these foundational sets, Platonistic structures, or the nominalist concreta. In contrast, category theory, and this is what makes it different from these approaches, it can be used to frame an in-ray version of mathematical structuralism where the axioms aren't taken as Phrygian. They're not taken as truths, they're taken as definitions. So if we look at the Hilbert tradition of axioms, right, these category axioms then are taken as schema for what we say about any or all systems that have the same type of structure. So how does this play out mathematically, and what does that mean for our various structural realist positions? So this shows why, to quell Bain's mathematical concern that category theory doesn't need either set theory as a foundation or structure-theoretic Platonism or theoretic nominalism as a background theory. Category theory does not need to consider what its objects and arrows, or indeed its categories, themselves are or are made of. The category theorist just says, I'm going to take this as my object. I'm going to take this as my arrow. And doesn't say, oh, but what is it really? So, of course, there are identity conditions for objects and arrows and for categories themselves, but those are given mathematically, right? For objects, they're given in terms of isomorphisms, and for categories, they're given in terms of equivalence of categories. So no one runs around going, oh, but we don't have identity. So it's in this Hilbertian sense that we're able to understand the claim that category theory provides the best foundation for mathematical structuralism. It's the tool used to best organize or unify what we say about the types of mathematically structured systems. Now, Bain does hint at this difference between the Phrygian and the Hilbertian conception. At the very end of his paper, he says, more generally, the issues of fundamentalism, category theory over set theory, concerns not just the practice of using set theory as a meta-language for category theory, but the status of reference of this meta-language. Are these references ultimately sets of categories? He mentions Audi, for instance, observes that the axioms of set theory are typically taken as making existential claims about a single universe. The axioms of category theory are taken as definitions of things which are assumed to exist in some foundational system. So all is good here, except for the part where he says which are assumed to exist in some foundational system. And it goes a little wrong before then, where he says making existential claims about a single universe. Here he's mixing the Phrygian use of axiom with the Hilbertian use. So again, for the Hilbertian, axioms are definitions, full stop. You know, well, why are they definitions? Right? How do they differ from truths? We just said they're definitions. So the various category theory axioms then are taken as Hilbertian. So for systems organized by the EM axioms, right, we have sets, functions, groups, formulas, rules of inference, but we don't ask, well, what are those made of? Right? Similarly for the other levels of analysis. So for systems structured by the CCAF axioms, right, those objects, set, group, sheaf, are nothing but objects in a system that has that structure. Similarly, for systems structured by ETCS axioms, sets, functions, elements, relations are nothing but objects in a system that has that structure. So more generally, for a category theoretic view, objects, that is, things that are structured in terms of objects and arrows, are nothing but positions of systems that have that type of structure, as we saw. So now let's recast the supposed distinction between BOSR and ROSR in these terms. So both say that we can speak of objects as positions in systems that have a structure. ROSR says that, oh, and in doing so we eliminate reference to object, and BOSR says we merely relabel. So we're left with a big notion. But if we view these now from this category-theoretic perspective, right, we characterize the structure of a system by Hilbertian-style category-theoretic axioms, then we can speak of an object as nothing but a position in a structured system. Because in relabeling or schematizing in that Hilbertian sense, we thereby eliminate reference to Phrygian objects. And so we don't need to face questions about their identity conditions, questions about what they are really or what they're made of. So let's consider this recasting of ROSR in this category-theoretic way. And let's look at the mathematical and physical examples that Bain gives. In the mathematical example of the use of set, Bain himself questions whether elements are truly eliminated or if they're only relabeled. But again, what an element is in set is an arrow. That's it. You don't say, what's the arrow made of? There is no appeal to relata in this case. Right? So in set, the axioms are schematic. So talk about identity conditions in terms of elements qua relata that make up sets as Phrygian objects not only is not essential, but it doesn't make sense. So in schematizing or relabeling elements as arrows from terminal objects, we've eliminated reference to them as relata. We don't then ask, well, is that thin relata, thick relata? They're gone as relata. In the physical example, the use of sheaves, Bain claims that sheaf-theoretic Einstein algebras can be used to show that space-time points qua manifold points are eliminated, and Lam&Wüthrich counter, sheaves themselves have elements, and those elements are defined over open sets, right? Possibly constituted by points of the underlying manifold. Oh, now we have points of relata. But as Bain points out, there is some confusion. Element, in this sense, in this category-theoretic sense, is to be understood as an object or an arrow. And so in this sense, element as manifold point need not be taken as category-theoretically constituent. There is no notion of constitution. So again, in sheave X, as in sets, the axioms are schematic. So talk of elements qua relata that make up sheaves. Not only is non-essential, but doesn't make sense. So I do think Bain succeeds in his use of set and his use of sheave X to show that one, you don't need relata, and two, you don't need set structured objects. But Lam&Wüthrich, they're ready. They say Bain has not shown that the boundary constructions that underwrite the physical motivation for the use of sheave X cannot be represented locally, and so without appeal to this sheaf-theoretic model, nor has he shown that topological quantum field theory is more than a tool or a Troy model. Now here is, I think, where they do succeed. Because here is where the problem of Bain really occurs. So Bain claims to have shown that a category-theoretic formulation of fundamental physics is both physically motivated and has physical significance, and so can be used by the OSR. The problem is that he hasn't shown physical significance. So, how am I doing for time, anybody? Okay, good. So they consider, on the suggestion of Pooley, whether Bain's ROSR could be justified metaphysically. Right? So he hasn't quite shown physical significance. Could he run this underdetermination argument and so establish it metaphysically? That is by an argument that the reformulated theory was the metaphysically more perspicuous account of the empirical phenomena identically saved by two formulations. So they hold, however, that Bain fails to consider such an argument. But Bain, at the end of his paper, sums up his entire argument as one of Jones' underdetermination, that is just the type of underdetermination that's suggested by Pooley. So at the very end of his paper, Bain takes up the concern that it's one thing to demonstrate that from a formal point of view, category-theoretic representations of structure are independent of relata, and another thing to argue that structures in the physical world are likewise independent of relata. So to quell this concern, Bain then distinguishes between metaphysical underdetermination and what Pooley has termed Jones underdetermination, with the aim of using the latter, that is the fully inspired Jones interpretation, to underwrite his argument for ROSR. We can get back to those differences if we need to. So in the end, Bain's entire ROSR argument is intended as an inference from Jones underdetermination plus semantic realism. He says the current essay motivates ROSR by different formulations of a single theory that disagree over the ontological status of objects. The inference to OSR from Jones underdetermination depends on some form of semantic realism with respect to theories of physics. It assumes that we should take the claims made by theories in physics at face value, and so provides the connection between mathematical representation and physical phenomena. And it assumes a naturalistic approach to metaphysics, one in which the metaphysical commitments are informed by contemporary theories of physics. So, however, one important category mistake remains for Bain. And it's one that undermines, in my opinion, his entire argument. So while Bain's examples from the structure of theories of fundamental physics are indeed physically motivated, he gives a reason for why one should presume or prefer the category-theoretic formulation over the set-theoretic. As Lam&Wüthrich pointed out, it remains unclear whether they're physically significant. So here's why. In both the sheaf-theoretic formulation of Einstein algebras and the Hill formulation of quantum field theory, the mathematical structure appealed to is at the theoretical level of mathematical representation of the structure of a scientific theory. We have no empirical content, as opposed to being at the object level of the mathematical representation of the structure of physical phenomena. So bringing us back to what we saw in this hierarchy model, we're at a theoretical level. We're trying to make claims about the structure of the world, but we have no midpoint where we've actually made contact with the physical world. So clearly any appeal to semantic realism, which is needed to underwrite ROSR's claim about the structure of the physical world, or the physical structure of the world, and so about physical significance, needs to be made at this object level. So it's unclear how he can appeal to Jones underdetermination in this case. So I'm going to skip that because I'm just going into gory detail. So let's return then to the two claims that Bain uses to underwrite his arguments for category-theoretic ROSR. The first is that category theory provides a more general notion of structure than does set theory. The second is that specific examples from fundamental physics show that category theory is better for running ROSR type of arguments. Recall that one has two parts to it. One is to conceptually show that you can use set to show that there's a conceptual coherence talking about relations without relata. The second is to mathematically show that one can use category theory more generally to define a structure as an object in a category, and so to talk about structures without set objects. So given his category theoretic mistakes, it's not clear that Bain has succeeded in these. However, I think, or I hope I've shown that both with respect to both A and B, was that given a Hilbertian reading of the category-theoretic mathematical structuralism, that one can talk about types of structured systems, including set structured systems, in terms of structured objects and arrows, without concerning ourselves what they are or what they're made of. Whether these are sets or elements or your elements or bare elements, or you want to call them. Thus, I have mathematically shown that generally category-theoretic objects need not be structured by sets qua relata. And in set-theoretic relations and structures need not be structured by elements qua relata. I've also conceptually shown that this version of category-theoretic mathematical structuralism can be used to collapse the distinction between BOSR and OLSR. And I think, what I'd like to say is this offers a quietist position. Maybe this is just a linguistic problem that we've set up, and we're just throwing more formalism at it, which is not really helpful. So finally, with respect to Bain's claim 2, that specific examples from fundamental physics show that category theory is better for OSR type arguments. I conclude here with an analogy. So just as I've argued that Old French commits a category mistake by conflating the level of philosophy of science with the object level, so that there's no quick ROSR route from his use of set theoretic partial structures account of the shared structure, the shared mathematical structure of scientific theories to the structure of the world. Likewise, Bain commits a category mistake by conflating the theoretical level with the object level. And so there's no quick ROSR route, even if we appeal to Jones' underdetermination from the category-theoretic representation of the shared unified theoretical structure of fundamental physical theory to a mathematical representation of the structure of the world. We're trying to get at the structure of the world. So what then is the relation between science and reality? That's what we're supposed to be talking about. So I'll say a few things about that. So I think that relation should be found at the object level, which considers the shared physical structure of the phenomena and the world. However we characterize phenomena, whether it's data models, we've seen the problems with that. But at least it has to be at the level of the phenomena and not at the level of the theory. So the ROSR, BOSR debate cannot be settled mathematically. If it's to stand, it must be settled either metaphysically or physically. Yet insofar as metaphysics, like mathematics, only tells us what's conceptually possible, it cannot be settled metaphysically first. Right? So I think this project that we've seen growing by leaps and bounds, well, let's come up with some modified bundle theoretic view that could underpin ROSR. I don't know what that's getting at. So only physics tells us what the mathematical structure of the phenomena is, and so any naturalized metaphysical structural realism positioned from this to the structure of the world must be found A, at the object level, and B, at the local level. That is, the practice of science, where science actually happens, where theories have empirical content. So unless the physical theory we're talking about is so fundamental that it's a theory of everything, there's no global structural realist argument from the structure of the physical theory to the structure of the phenomena, and then to the structure of the world. And so this is, my advice to not only frames that are category theoretic, set theoretic, bundle theoretic, is let's make sure that we're running our structural realist argument, if we want to run one of those, at the right level. Because only then are we going to make a connection between what our science tells us and maybe what the world is like. That's it.
Okay, so we have time for some questions. We started late, so maybe.
So I was just wondering, is there scope in this, in the structures and objects and categories? Is that right?
That's Bain, yeah.
Is there room for some just self-refuting kind of self-undermining accusation? Is that the structures and objects and categories, we've got to eliminate objects and we should eliminate structures? Is that good one for that?
Well, here's the thing. I think that it's unclear what he means. I think what he might mean is a structure is an object in a category. Object meaning category theoretic object, right? So you're going to use then the CCAF axioms to frame what you mean about that. But it's unclear that that's what he means. And I think you're right. Once you say a category is a structure, what is it? An object is a structure. Yeah, you've got both objects and structures there. So the very characterization seems self-defeating. Right.
In philosophy, it makes a difference to put things in the words.
Single quotes, double quotes.
I'm sure if I understood this, I would agree. But I have a question. I don't have a question. I have a complaint.
Okay.
But it's not directed at you. But it's directed about this literature in a way.
Yes.
So, I would suggest that maybe as a rule that if you're going to use examples of finding examples from physics that vindicate structural realism, you find examples that don't actually have mathematical terms in the very names of the so you got algebra in one case and topology in the other.
Yeah.
Neither of them are physics. I don't know much about Einstein algebras, but topological quantum field theory, it has no no local physics in it at all. It's beautiful with all this stuff of cobordism theory, and it's gorgeous, but it has no so it's kind of like, and this is not just here, it's a general thing. So I remember going to the PSA many years ago where a bunch of structural realists brought in all these people from quantum gravity. And quantum gravity is a research program, it's ongoing, they're exploiting various mathematical techniques and insights, but it's mostly just math. And so they showed up and they didn't even know that their stuff was that deep that they were vindicating all this structural realism as well as the program. It was amazing. They were amazed. And then afterwards you're talking to them, they were, what is that structural realism stuff? They're so ensnared in this structural realist trap. And so it's a general thing, and so it's like as if Hartree Field wrote, science without numbers, but picked as his science the ABCs. It's too easy.
Yeah, I think it's really interesting. So if you compare these examples to the example that French often uses, which is the role of group theory in quantum mechanics, right? And how we can use the group theoretic structure to kind of carve out our particles, their properties in structural ways, right? By looking at basically the morphisms between the different groups and satisfying conditions of symmetry and so forth. Okay, but let's remember that in that situation, we have, as Steve points out, right, we have the Weil project and we have the Wigner project. And one of them is to work out this theoretical underpinning, and the other is to say, okay, what's the empirical content of this? So we do have both components that we need. I don't know that it's successful because I don't think ROSR can be successful, but at least in that situation, I think we're running the argument from the right level, namely from the empirical or the phenomenal level and not from this theoretical level. I think there can be no structural realism argument from the theoretical level. So yeah, I'm with you.
Other questions? Yeah.
I was a bit unclear about the way we use the distinction between Frege axioms and Hippardian axioms. I mean, I know the difference. I think I know, and I think you made it clear. But most of the arguments were at the object level of a scientific theory also. In that when you do it the Fregean way, there is something outside with the objects and you've got a capsule, whereas when you do the Hilbert way, there's just a structure or whatever satisfied. So do you gain something by moving this to a category theory level? Is that the objects are eliminated altogether when you do that in category theory?
Well, here's the thing. It's not that they're eliminated, but you only call them in as you need them, right? So it's not that we eliminate elements, right? We call them in as we need them to characterize. So for example, in the ETCS structure, to characterize set structure and to characterize what we mean by relation. We still got relation as, the ordered pair, right? It's just that we're not talking about elements anymore, we're talking about arrows, right? So we call them in as they're needed, right? And that's the Fregean aspect, or sorry, the Hilbertian aspect. We call them in as they're needed to satisfy our axioms or to talk about how this structure is related to that structure, but we don't presume that there's some sea in which all mathematical entities are floating. Now, here's one of the things that might become problematic. Someone could say, oh, but wait a minute. In physics, right, I do presume that I have a world set and that's what my axioms range over. Let's take my sentences in that case. And then, you might say, well, look, there's a fundamental difference, and so, but that doesn't mean, oh, let's go back to reading our mathematics in this Fregean way. It means, okay, well then let's be sensitive to the fact that we're using sentences in a Fregean way in physics when we're not using them in that way in mathematics. So one of the ways to think about this, right, when you think about, what I found interesting is, look, even the notion of element as given by ZSC axioms isn't a primitive notion, right? The primitive notion is set, right? And element is a derivative notion. You don't have freestanding elements. But what happens is that intuitively, when we go to then use that formalism, we say, okay, I'm going to use whether it's a model theoretic formalism or just straight relational or structuralism. I say, oh, but I want this thing to stand for that physical thing, right? And so intuitively we say, oh, that's like the element. But mathematically, formally, you never have that bare notion. Now you could use your elements, you could do different things. But I think you can't just go, oh, my mathematics is telling me this, therefore my physics must be this way. And I think likewise, let's decide, if we want to make decisions about the world is fundamentally individual-like, okay, but then realize what aspects of your mathematics aren't going to allow you to capture that.
But am I right in thinking at this point it is independent of the category theory formulation? So that it's kind of Hilbertian mathematical structure and even Fregean mathematical structure?
Yes. Yes. Yeah, so you could be a set theorist and run this Hilbertian style approach as well. I just think what ends up happening is that just like if you try to use the CCAF axioms as your foundation, you're going to run into size issues, right? So now you've got the set of all sets. And so if you run that argument just using set alone, you're going to run into some size restrictions mathematically.
I hope I'm not the only one in the room who wanted to ask, what is Jones underdetermination?
Right, okay. Yeah, I kind of, it's just, one is when you have two theories with the same, here we are. So metaphysical underdetermination occurs when you have the single formulation of a theory, say quantum mechanics, is used to show that objects, because they can multiply be interpreted as individuals or non-individuals. So this is it's usually metaphysical underdetermination that we see French and Ladyman kind of appealing to. Jones underdetermination occurs when a single theory, not its formulation. So a single theory admits of different formulations. So tensor formulation versus Einstein algebra, that are one under a realist interpretation suggesting compatible entities. So in the tensor formulation, you're going to have space-time points, and as Bain argues, that in the EA you don't. So it's whether you have a single formulation or a single theory with different. Right, exactly. Yes.
More questions?
We had a conference here, the book bash a couple of years ago. I'm thinking about the argument by the wife of the couple that had the two books.
Laura Ricci.
Sorry?
Laura Ricci.
Laura, and now, is it with her? Okay, she did one of the things that she was emphasizing and that Halverson was expanding about was she had looked, if you think of different interpretations of quantum mechanics, and she would argue that the one places where one would be appropriate would be incompatible and different from others. It would be one thing that would work in all of them.
Right.
Is that an example of what he's calling Jones underdetermination?
Yes. Yes, I believe so.
Okay, that's all I wanted to.
Okay, well, I'm just